Anyone want to be our live video editor for the event?
What does that entail?
Basically, just sit at that desk back there and like click on the screen camera when I start showing something, or click on my face when I'm not really showing much on the screen, and then occasionally when I tell a joke, you bounce to the audience so you can see them laughing.
Do you have a laugh?
Yeah.
Show me real quick.
Yeah, I'll show you. Yeah. Okay. So put these on, and then what you're gonna do is basically whatever's red is the one that's currently.
Oh, okay, yeah.
You know.
Yeah.
And then like to bounce to the audience, it's there, although no one's. Can you guys scoot up? Like nobody's in the camera. Like,
just like the first two rows, probably.
Yeah, stay in the first two rows if you would, please. I would very much appreciate it. And then when I start, showing my source code, yeah, that'd be great. Thanks.
Yep.
Hey, the food. Did they realize what happened?
Yeah.
Did they have it ready, or did they not have it ready?
They had it ready. For the most part, they had it ready.
Okay, cool. Thanks. Sorry for all the trouble, but I figured it was a big enough problem that it's probably worth going back. All right, so thanks for your patience today. We are now streaming live on our Blockchain Utah YouTube channel, and glad to have you guys with me today. I'm super excited to be showing you guys this new tool called Foundry. So if you recall from a few months ago, we used a couple of different tools for development. We used Hardhat for our smart contracts and deployments and other things like that. And then we used UseDApp for the front end that's talking to the smart contracts. And what today's presentation is going to be about is a new tool that would really be a replacement for Hardhat. So this tool pretty much has most of the things that you get from Hardhat, except that Hardhat's probably a little more popular, so there are like more plugins for Hardhat. But there's some really cool aspects to this Foundry tool that I wanted to show you. And like one of the main ones is that you can now code your tests for your smart contracts in Solidity rather than in JavaScript. So what I'm going to show you today is, if you recall from the last time we did this, we had a polling system where it's like you could create a poll, then people could write questions on the poll, like what's your favorite color, red, yellow, blue. You could vote on the poll, and we have a set of smart contracts that manages all this. And so what I thought we could do today is take that same smart contract and rewrite the tests in Foundry, to use Foundry, and I could kind of show you that process. So let me just open up. Yeah, here we go. That original code, so we can get a feel for it. I'll do one thing here really fast. Oh, and by the way, the code that we're going to be looking at today is at this GitHub address that I have down here. So
can I ask, is
sure.
there any benefit to being able to write the test in Solidity as opposed to TypeScript or JavaScript?
There's several benefits. One is that the Foundry tool executes all the tests in parallel and the compilation in parallel. So in my experience so far using it, it's been about twice as fast to compile and run the tests as the JavaScript is. So that's really nice. There's also some interesting things that it does in more advanced testing. It has this concept called Fuzz Testing. And with Fuzz Testing, what you're doing is it's generally a testing strategy where you're sending a lot of different data parameters to your methods and seeing if some of them at the extreme ends will break things, right? So I'll take a minute to show that as well. But it's both faster, and then I guess just the idea that you're not spending as much time sort of serializing the data from Solidity into JavaScript and back, you know, in order to test it. It just is a little less clunky, a little more elegant, you know. And you'll see it. I think in some ways it gets more simple as well when you're writing your tests in Solidity. Okay, so I'm going to just... So one thing just to clarify, that my first Ethereum dApp, I have a new branch in it called Foundry. So if you want to see the code we're writing today, you'll just open up that branch called Foundry. But I am going to check out the main branch so that we can see the way the code used to be here. So we have this contract called polls, and let me just expand this a little bit. And we have some data structures defined here. We have a title for a poll. We have a question that the user gets asked. We have a number that counts how many options there are for the answers of the poll. A number that counts how many people have voted on the poll. We have a mapping of strings that holds a vector of strings that holds the different options people can vote for. So in that case of like, what's your favorite color? This set of options would have red, yellow, and blue. We then have a vector of integers that holds how many votes have been cast for each option. And we also have a mapping of address to integer that basically keeps track of who voted for what. So if that user has voted for a certain option, the option that they voted for will appear there. And we can toggle whether they voted on or off. So like if they click it once, it will accept their vote. If they click it again, it will toggle their vote so they haven't voted yet. Then we have what is this? Yeah, an index that just holds like what the next open slot of option is, I believe, if I'm not mistaken. And then the owner of the poll, the person who created the poll, is tracked there. We throw an event called poll modified whenever you have interacted in any way with the poll that modifies something. We also, just for convenience in the UI, we had this data structure that keeps track of the names of the owners so that when you're displaying all of these polls, you could actually display some kind of useful person's name next to it. We won't, what's that? KYC. Yeah, I mean, in a way, it's like we're revealing the identity of the, well, whatever they want to put in there. But like today, we'll probably mostly just be looking at Solidity, so we're not going to look at the UI. But we saw that in one of our other meetups. And then we have these methods, right? You can create a new poll. You can get data, get an existing poll so that you can display it. You can basically, this is a private function that I'm used just to verify that the poll is actually there and to throw an error if it's not. If someone tries to access a poll option that's not there, then I throw this error. So these are some methods, internal methods that I'm using to make sure that the user isn't trying to access data that's out of bounds. Then I have this method for adding options to a poll. So when you create a poll, you're not actually creating all the options at the same time. You first create the poll with the title and the question and the owner name, and then you add an option one at a time. And then, you know, there's a method for removing an option from a poll if you made a mistake, getting the total count of options so that you know how many there are that if you want to enumerate through them. In many ways, you'll find, for those of you who are kind of new to Solidity, that like everything is There's no convenience features at all. It's basically just like, you're writing it all from scratch and doing all the heavy lifting yourself for the most part. And I think that's good in a way because every op code that you write in Solidity costs gas. And so it's sort of like, as the programmer, if it seems like what you're writing is taking a lot of lines of code, it means that it's going to also be an expensive operation to run. So in a way, it's sort of like having a method that would do a lot of heavy lifting for you might cause you to, waste op codes, and not be as efficient as possible. We have something to change a poll option, to change a title, to change a question. We can see how many votes have been cast. We can toggle an actual option for a given voter, and then we can see their status. So these are the methods that we have, and we now want to test those methods. And if we look at the way we used to write tests really fast, I guess it's a little big. Here we go. We basically have a kind of Mocha-like interface for JavaScript, and we have some things we set up beforehand. I have this little helper method that checks to see if a poll modified event has been run. And then before each test, we essentially deploy the contract and gain access to the contract instance that's been deployed in our local network. And then we interact with that. So when I test that I can create a new poll, I first have to use my utility classes to format a string in a format that Solidity actually wants. One nice thing about doing Foundry is that we don't have to do these string conversions when we're writing our tests, right? So you'll see that in a second. Then I, assert that before I create the poll that the count of polls is 0, and then I create it. I make sure that I get a modified event that gets actually sent, and then I test to see that the new count of polls is 1, so I've successfully created the poll. So let's take a look at how we would do that, and let me actually also, just for fun, we're going to actually run this, the old one, right? So it's not too bad. Let me make this bigger so we can see what's going on. It's not too bad. We're running our tests in 3, almost 4 seconds. But this is only one contract. And I am also, I am timing the compile time as well. But just to give you an idea, I'm working on a project that has 200 contracts in it right now. And it takes minutes to compile all the contracts and then more minutes to run the tests. So a total of 5 to 10 minutes, to run everything. And when your feedback cycles are that slow, it really does slow you down as an engineer. So the faster you can make that, the better. So let me, I'm going to bounce over to the Foundry version of this. And I'm going to comment out most of these, but we'll test them one at a time. All right, so we've got this same, oh, and I should show you as well. So if I go to a brand new directory and go test Foundry app. What you're going to do is you're going to go Foundry init. Forge init. So Foundry is the name of the project, but the name of the actual command CLI is Forge. And Forge init will kind of create a basic directory structure for you. that looks like that. And it's actually running in Rust. So they, instead of having to actually start like a hard hat, a local Ethereum network on your machine, they basically are simulating a Solidity environment in Rust. So that, I think that also makes it a little bit faster. I'm not totally sure how it compares to the Geth or whatever, you know, the whatever network you'd be running for hard hat, but I think it's pretty fast. Then they create like a source folder where your contracts go, and then a test folder inside of there where your contract tests go. And then this other stuff in lib is just some helper methods that you're going to use during your testing. So let us basically what I've done here, just to give you an idea, is I've pretty much just copied my contract into that same format. I just copied polls into the source folder and then created a test class called polls.t.sol. This safe thing I'll show you in a sec. That's kind of coming later. But let's take a look at that. Let me go into my first Ethereum dApp Foundry. Okay. And if we go forge test, then that first test passed, and if I were to time that, you see that it took just less than half a second, so it's pretty fast. And let's look at what this is doing then. So there are some cheat codes that they have here. If we look at, I'll hide that sticky a little bit. Cheat codes, here we go. There's a reference here. So there's a contract in this environment for Forge that contains a bunch of methods you're going to call in order to do some of the kind of mocking and stubbing and other things that you need for a regular test framework. So when you're writing tests, you sometimes need to like say, okay, check to see if this throws an error, for example, right? Check to see if this calls a revert method. In a way, that requires almost that you like hop out of the environment that you're running it in order to tell it to kind of look for something. So, so there's a contract that's been added that allows you to do things like that, and you just have to use an interface and refer to the methods in that you're calling. So you can see, for example, that there is a warp function for setting the timestamp of the block to what you want to set it to. There is stuff for like finding the address of a certain private key that's been created for you in the network, because you typically have these like boilerplate identities that you use to do interaction between several users. You have things like prank, which says run the next command that I'm going to run as this user, or start prank, which says run all the commands from here on forward as this user, and then stop prank to go back to whatever it was before. Expect revert is like a very common one where you're saying like this should throw an error. Expect emit is what we use for when we're expecting an event to be generated. So so these are some of your cheat codes, they're called, and so you can see that I'm referring to some of those here. So first I import some of these test functions that we are going to use, and then I import my actual contract that I'm testing. Then I'm going to just refer to the cheat codes that I care about here. So I'm only using some of them, so I'm just only bringing in a few of those. And then we write a new contract that is the contract that will test the other contract. So we have we declare an instance of our polls contract, and we one thing that's nice about this already that you'll see is that you haven't had to deploy anything. You basically are just instantiating it right inside your own contract and testing it right there. Then I do this one command here to tell it where to find the cheat codes contract that it will use for those other things. How are we doing over there with the food, guys? Is it ready? Feel free to go mill around and grab your food while I'm talking here, guys. Normally we would eat for a bit before and then join in, but since they screwed up the order, we just kind of had to do it this way. But if someone would scoop me up a decent bowl, just in case. Thank you. Yeah, because last time all the food was gone by the time I was done talking. I was really bummed. Anyway, okay, so this event, poll modified, is one that my own test is going to throw. The way you do events to test whether your contract throws an event is you generate an event that's the same as the event you're expecting, and the test will then match them to see if they will check to see if they match. You'll see that in a sec. And then I created two different addresses or two different identities for the users that I'm going to pretend to test with here. So I have a few things that are run during setup. I instantiate a new instance of the polls contract, and then I assign to Alice and Bob address 1 and address 2 inside the network. Then this first test first checks to see that there are no polls. Then it calls this cheat that's expect emit. Now this, I had to research a little bit. So the way events work in Ethereum is that you have 3 topics and then you have a data section. So what this says is match, check to see that topic 1 matches, check to see that topic 2 matches, check to see that topic 3 matches, and then check to see that the data matches, right? So by passing false to everything except the second one, I'm saying only check to see that the second topic matches. In this particular case, the second topic is the identity of the user doing the modification. I wanted to check that the data matches as well, but I was getting an error when I did that. And I believe there may be something a little bit buggy with the event matching because I saw an issue on it currently in the repo. But this still at least checks that the event was thrown. It may not check that all the details are there that we want, but we can put up with that for now.
Is it just like a multiple instances issue? Is it like comparing things that are similar instances, but they're legitimately different pointers? Or is it something more complex?
We can actually test that. So if I change this to true, and I go to the test and run the test again, we now get a failure, and it says expected and emit, but no logs were emitted afterwards. And one thing that I can do here, this will show you kind of the trick for how to debug your tests when they're not working. So if you pass to Forge this VVVV, that's saying give me the most verbose output possible. And if we look at then what it's doing here, we see that the event emitted had 2 topics and a data section. And